So here is my discussion post 4, describing what life might be like on these planets um, that we learned about in this video. So the first planet that was discussed was Tres 2b, and also for future reference, sorry if I butcher any of the planet's names. I didn't quite get them down in time. But Tres 2b is considered to be the darkest planet that we have yet discovered. It reflects less than 1% of all the light, so it's very absorbent, and that's due to the gases that are on this planet. It glows a molten red color and is like a 1,100 degrees Celsius. So life on that would it it would we would have to adapt to a different like lighting scenario. Just think about like my thought is that even if we had lit like a candle or like have current like lights like how we do now, that even then the gases in that system would still absorb those lights, making it therefore impossible to illuminate anything. So eventually I'm thinking our species would have to adapt to um, that situation through generation and generations of evolving, and we would eventually be able to like have, in a sense, night vision just naturally, um, within our bodies and through adaptations. The um, the next planet was 55 Cancri E, which is almost the opposite in a sense to Tres 2b, where it illuminates almost diamond-like because of um, it illuminates really brightly, and it's basically just a giant diamond due to how carbon heavy it is. It's about 2 times larger than Earth, and it's so dense that all the carbon that's in its system is condensed into diamond. Doesn't exactly seem very lifelike for us or any like living thing. If you were to think about it, there really wouldn't be much of a way for us to like adapt to that, because even for trees to exist, they need the carbon that we breathe out in um, in a gaseous form. But this planet doesn't give enough gas carbon due to its density. It condenses that carbon into diamond. So my guess is that we wouldn't be able to get the oxygen we need from living life, like plants and such, because the they wouldn't be able to take in the carbon that they need to emit oxygen. The next planet was Gliese 4436b, which is just a giant ball of ice on fire. Once again, gravity is immensely strong here. That the reason it is the way it is, and a ball of ice, is because the gravity um, brings all of that form to its core and condenses it into solid ice. But the temperature of the surface temp of the planet itself is so hot that it is on fire, and so the reason that it is able to be kept as ice that is on fire is due to the surface temperature being so hot, but yet the gravity being so strong that it's condensing everything into this ball of ice. So the next one that they had was HD 189773b. Looks like they didn't get exactly too creative with these names, but how can you eventually with names running out? So here it's constantly raining sideways, which wouldn't be a problem, but that rain is glass, and that's because of the particles in the atmosphere that that are silicon. Not really sure, but these particles are condensed due to high surface temps. This silicon then condenses into glass as we know it, and the 4,000 mile per hour winds on the surface of this planet constantly push this condensed silicon particles or glass, just keep whipping them around, which obviously wouldn't be possible for us to even remotely like get close to that planet. We wouldn't, we couldn't survive. It just isn't possible. The next planet was WASP 12b. So this one's pretty obvious, but we wouldn't be able to live on this planet just because of its current state and condition. It's being eaten alive by its own star, and because it's so close to its star, that it has insane heat temperatures. If we were to live on this, we would more than likely just be eaten alive by the heat. It's about the size of Jupiter, but is losing so much mass so quick that that it's an egg shape. So obviously, even if it wasn't being like eaten alive by its star, then we would obviously the gravity on that like planet being egg shaped would have a different sort of like different sort of control. Like it wouldn't be, as Earth is mainly spherical. It offers more like an easier like understanding of gravity, just kind of like all just pushing in the same direction towards the core. But like in an egg shape, you'd have different gravity pressures on different angles and different sides. So it'd be interesting to be able to like live on a planet that was egg shaped, because then we'd be able to study different gravitational pressures, and hopefully to further our understanding of what it would feel like to live on a planet such as that. The next one was Gliese 5C or 5A. I didn't catch that one. This one was one of the first ones that was likely to support alien life. It orbited a red star or red dwarf star, something like that. So if you were to look into the sky while living there, it would be a constantly red sky. This planet is tidal locked. So it's like there's no like rotating on its axis. So there's always a side that's facing a star and a side that's not facing the star, sort of like our Earth. But the difference between us and them, or us, or like our planet, Earth, and Gliese and this planet, is that the side that's facing the star is so hot that if we were able to like stand on that planet on that side, we would melt alive. But on the contrary, if you were on the opposite side, you wouldn't have that heat, but it would be so immensely cold that if you were to stand on that planet on that side, facing away, you would freeze. But the reason that there is a possibility of life is that there's this narrow strip of land that operates in between those two sides that offers a habitable zone. Yeah, to take that for how I pronounce it, but a habitable zone for human life, and well, maybe not human life, but just for alien life in itself, for something to grow. And the next, wow, I'm stumbling over words now. The next planet was WASP 17b. This one was extremely strange because of its size in itself. It was almost 2 times the size of Jupiter, which is our largest planet in our solar system. But with this, it physically breaks like the laws that we have on how large a planet should be. One of the weird things that goes along with this is how low the density of this planet is. We call it in scientific terms, which is odd enough because you wouldn't really think this term to be scientific, but it's called a puffy planet. And another odd thing with this planet is that it's in a retrograde orbit, so the way that its star is rotating, it orbits the opposite way of that. I'm trying to think what kind of effect that would have on us. But yeah, I can't think at the current moment what effects that could have on our planet. But yeah, and so we'll move on to the next one. So HD 188 753 AB. This would be, I think, personally, would be super cool as long as you had eclipse glasses probably at all times. Um, because it has three stars, three suns in our case, I suppose. So it'd be super cool because you would see three shadows at any given time during the day. There'd be constant eclipses as the stars would move in front of one another, and it would be it. The video said that you'd have the most amazing yet strange like sunsets and sunrises, which I think would just be really really cool to experience in and of itself. So life there, honestly, would be just, I guess in a sense, it'd just be like almost over, like, you'd have like almost over sensory to like the stars in itself, just having to constantly like be aware of like what's going on there and like being ready for like eclipses and just having to deal with that all the time, which could be like really annoying, honestly. The next one was GJ 1214B. Um, Not that we couldn't live here, I don't think. But it's in a sense that there's no land and it's solely like made of water, which is why they call it the water world. The core in itself is coated of solid ice, not because how how cold it is, but rather due to pressure that forms that ice from the water, which they call is ice 7. Um, but my question is how would you start building life on that planet? If we were to send somebody there, how would we start like a colony? Like with something that has so like deep of water, like the materials you would need to build houses or anything, any form of land would just be just an insane and immense amount to like even get started. So it just seems so unlikely that we'll ever get to experience something like that. Not to mention, obviously, like all the waves and shit that would have. Oh, sorry, didn't mean to curse. All the waves and stuff that would constantly be crashing upon like houses and stuff. Like, how would you deal with that? Like tsunamis and all that such things. And finally, the last one was Kepler 438b, which was the strangest, I guess, strangest in a sense, but it was the most Earth-like to date that we have found, with an Earth similarity index of 0.88, which one being the highest being identical to Earth. It's a rocky world. It has, which most likely they believe that would have liquid water, which is the water that is needed to support life. It's in the Goldilocks zone that is not too close but not too far away from the sun or the star that it orbits. So it would be habitable to sustain life for us, where we wouldn't melt, we wouldn't freeze. Um, and overall, it's just the most compatible for life, such as our own. So if we were to send somebody, it's a good chance currently that we would survive if we'd get there. Now, obviously, I don't know what kind of study they've done on like what sort of like atmosphere it has, but currently it seems like we'd be able to survive on said planet. And these are the 10 planets that he had discussed during this video.